Okay, Tenuka. We just discussed about recursive functions last day, right? I hope yes, we have discussed about recursive functions, and so then basically we were analyzing different. So we were trying different algorithms. We have done this turtle. We have done repetition tasks that we have learned to getting the odd numbers, even numbers, square numbers, triangular numbers. Those things we have done, and I hope that I have given 2 exercises that you to try. So I'm not sure whether you have done that. Let's go through that. Can you remember the exercise that I asked you to do?
No.
Okay. So that is this part, what we were. Okay, so there are 2 patterns that I asked you to try. So one is this, maybe before the last week. One is this one. I just asked you to print this pattern, right? So these 2 patterns. Actually, we have done these things in. We have done this thing in repetition too. But the problem is, how can we do the same in recursion? So actually these things also with the recursion we can try. So this is actually, so all the exercises we have already done in the repetition. But the thing is that if you need to practice this concept, so then we can try this again in recursion too. In recursion, what happens in the recursion, we are calling the same function again. So that is what happening in the recursion. So we are calling the same function. Let's say you have a function called def star. If star is the function, and inside the star function, you are calling the star function again. So that is what the recursion simply. You are calling the function within that function. So that is the idea. Okay, let's do that. Let's say I want to print stars starting from some number. Let's just start and end also ending with some number. And first of all, print. You can print asterisk the given number of times into, let's say, start. So if start is 1 asterisk will be printed, and after that so we are calling the same function again. I need to check this. I need to check whether if the start is less than or equal to the ending position. If only I'm doing this. If only I'm doing this. Otherwise, if only I'm printing and recalling the function, that is then I have to call for st+1 the next iteration and the same ending. That's it. So let me run this. Okay, when I run this, so let's start with some value. I'm calling the star function with starting from 1 to 5. So you can see it's printing stars from 1 to 5. How it happens? Initially, st is 1. 1 less than en is 5. 1 less than or equal to 5. Therefore, it's printing 1 asterisk into 1 time. Asterisk into 1 is 1 asterisk. Then it's calling the function again. Now st+1. Earlier it was 1. Now st+1 is, what is the value? Yes. When I start, st is 1, then st+1 is
2.
You're calling for 2 and 5. So then check in whether 2 less than 5. 2 less than 5. Is it true or false? 2 less than 5. Is it true or false?
True.
So it's printing how many stars now? Asterisk into st is now 2, right? So now 2 asterisks. Then after that, recalling the function. Now 2 plus 1. So what is 2 plus 1? The current st will be 3, right?
3.
Yeah. Then you are checking whether 3 less than this 5 ending. The 3 less than 5. Therefore, it's printing 3 asterisks. Then 3 plus 1 is 4. 4 less than 5, printing 4 asterisks. 4 plus 1 is 5. 5 less than 5 is not true, but 5 less than or equal to 5, it's equal to 5. Therefore, it's printing 5 asterisks. ST plus 1 this time is 6. 6, is it less than 5 or equal to 5? 6, is it less than or equal? No,
It's
more than, right? It's more than.
more than.
Therefore, it stops. So this is what the recursion is. Actually, similar thing we have done using the repetition. If you can remember the repetition, so we have done something like this. For I in range, we have say range y in range 1, you comma maybe up to 6. What you have done is print asterisk I times. So this is what the repetition. Repetition is easy because in recursion we have to check the condition. This is what the repetition. Repetition is basically calling a loop. So this loop will be executed and you will get this result. It's easy, right? It is easy, but the thing is, recursion is, in recursion you have to think how it works and apply accordingly. Okay, all these exercises you can do using recursion. Okay, so let's give a try. Yeah, let's give a try. So I hope that you have the codes related to these and these exercises. So shall we just give a try to implement this tree using recursion? These tree patterns using recursion, right? So this is repetition. So don't confuse. Repetition. Repetition is loops, but this is recursion. Recursion means calling the same function again. But both will do the same task. So using that, can you try to print the following? So I have given actually few exercises. Just give a try. So we have done this already in repetition, this 3 and this 2. So there are 5 now. So let's try to do that quickly. I'll give you some time. Don't worry, I'll give you, because like my idea is if we practice more, we can understand more. That is why I'm allocating more time to practice now. Like otherwise, like we can cover the theories and move faster. But ultimately, what remains with you is whatever that you have practiced. Therefore, let's do some practicing and move slowly. No need to become that much hurry. We can understand and move the concepts. So try these 3 now. So you can refer to the previous coding that we have done. I hope that you have that code with you. You can refer to those coding that we have already implemented. But the thing is that we have done repetition. Here now the challenge is you need to do this using recursion. Okay, let's do it now. First of all, I'll give you 3 minutes to try the first one, this one. Okay, arrange some set of folders and put the dates, and then keep these things, keep these exercises with. Otherwise, like in the time when the time that we are doing this, you will remember, but later you will forget. Okay, let's see the concept here. Actually, you have 1, 2, 3, 4, 5 asterisks now. So that means still the same concept. The asterisks are increasing. So if we have used in like repetition, so here, so let's say you have used repetition. So this is recursion. I'm keeping this for the moment. So let me keep as it is, and let's apply the repetition part. Let's say repetition 2. This time I have to start with how many asterisks? 1 asterisk, and I have to print 2 asterisks, 3, 4, 5. That means starting from 1 to 6. Why we are putting 6? I think you know that we have to put 1 more than the ending value, right? Because it will consider less than only. It's not going like less than or equal. So it will go up to less than 6. Less than 6 means 5. 1 to 5. Okay. So then what is in the beginning? What is in the beginning here?
Spaces.
Spaces. How many spaces in the first one?
4.
Okay. The next one?
3.
Next?
2.
Next is 2, and next is 1 space, and here you don't have any space. So that means there is another one going from 4 to 1, right? 4 to 1 or 4 to 0. So this is going like asterisks are increasing from 1 to 5. Then spaces are decreasing from 4 to. Okay. How can we get 4 right? We have these numbers 1, 6, these numbers are there. So can you tell how to get 4? How to generate 4? So if I write something like this, will it generate 4? If I write, okay, 5 minus 1 or 5 minus I, so what will be the value? 5 minus I. 5 is 5 I. What is the I value of I first?
1.
1. 5 minus I will become 4, right? Okay.
Yes.
So then I can say something like this now. Space multiplied by 5 minus I. Space multiplied by 5 minus I plus. Plus means you are going to join these two strings. This is not mathematical addition. This is called concatenation. You're going to join these two strings. One is space minus 5 minus I means 4 spaces, and so asterisk into I means 1 asterisk. 4 spaces, 1 asterisk. Second round. Second round, what is the value of I?
2.
Yeah. Then 5 minus I is
3.
3. Then how many spaces? 5 minus I means 3 spaces, right? Then I's value is 2. Then how many asterisks?
2 asterisks.
2 asterisks. 3 spaces, 2 asterisks. Understood?
Yes.
Okay, next round. So what is the value of I? Value of I will be
3. No, I mean,
yeah, value of I is 3. Then 5 minus I will be
2.
2. And I will be 3. So 2 spaces, 3 asterisks. Next round, I's value is
4.
4. Then 5 minus I will be 1. Then asterisk, there will be 4 asterisks. 1 space, 4 asterisks. Then last round, I will be 5. 5 minus 5 will be 0. So 0 asterisks. And there will be 0 spaces, 5 asterisks. Understood how repetition works?
Yes.
Okay, let me run this and show you the result. And here we are getting now the second pattern. This is the first pattern. The second pattern is okay. Now what you need to do is we have to implement the same, right? So nothing like you have to try. Don't just give up. Don't just think I can't do that. So just give a try. Okay, now you can see this is implemented. The next challenge is what? Next challenge is getting this from recursion. This is repetition, no, but we are not going to do this repetition using repetition. We are going to do this using recursion. So let's do it using recursion. So now, initially, number of asterisks. Do we need to change number of asterisks thing? Or is it similar?
Similar.
Similar, right? Asterisks, no need to change. Then what we need to introduce? Spaces, right?
Yes.
Okay. So how do we introduce spaces? Here, you have to say space into space multiplied by, yes, 5 minus st, right?
Yes.
Here you don't have I, no? 5 minus st plus this one. That's it. Understood? So what do you think? Is it difficult? Or, so this is star 2. So let's run it. So once the first one is discovered, the second one is easy, right? When you know the repetition, the recursion will be nothing. Okay, let's try this with now. Let's try this with recursion. Star. I'm telling, okay, 1,5, you are getting this. So if I tell the advantage of recursion, like here we can change it, right? 1,10, you'll get this. So similar to that, and if I tell star 2 function 1,5, you will get this. Oh, something wrong. This what's what went wrong. Into this, okay, into this 5 minus st plus okay, I'm printing it. The second round, what will happen? The second round st is 2, okay. Then 5 minus 2 will be st will be. What has happened to this? So let's try it again. It should generate. So I'm not sure why it's not generating. All right. space multiplied by 5 minus st. St is, you know, increment in 5 remains same. St plus 1. You're getting that st this time. That is the issue, right? Okay. Okay, so let's print the value of st. Let's print the value of st5 minus st. So I think we can generate something like this. Print st. So just to check, right? Print 5 minus st. Just let's see these values are they are or not. Otherwise, like we are finding something wrong. Star 2. Okay, 1 4. You are getting that first time. 1 4 you are getting. But in the next recursions, you got 1 and 4 for the first round. So what about the second round? Second round, you're calling this. Then this will be checked. St equal st plus 1. Restrict into st. St. Okay, something. Here I'm calling the first function. Okay. I have to call the star2 function, right? So this is the function name. So I am not calling. So see, it's very difficult to me to understand even what has happened. That is why I said always practice, right? So star2, this function name is star2. No, here it should be star2. Otherwise, it's not calling this function. That is why the result has come. Now you can try this, right? What is one you have to say? Space multiplied by 5 minus 5 minus st that you need to add to this part. And now you don't want to print this even, right? You can see when I run this function, it generates the pattern. Okay, star 2, you can see here it's generate, right? Star 1 will generate the other side, star 2 will generate this side. Even you can try some other numbers, see. But the thing is, then you need to consider about this value. If you're trying some other number, you need to consider about this value. This is actually en. So you have to mention, without mentioning 5 there, you have to mention en, right? En, actually en minus 1. Because en is 6, no? Then 6 minus 1. So let's try this now. Now it is universal. Otherwise for 10 it won't work. No, for 5 it will work. Now it's working for 10 even. I think something wrong again. A small modification. En is 10. You have to give en, sorry, en here. We are getting the exact number, right? Okay, you can see here, we are getting the. Now it's universally working for any number, it will work universally. Here, this one actually, the repetition one, you have to say, here you are giving 6 now, then 6 minus 1. If you are giving 6 there, then 6 minus 1 will come here. But here it is exact value because we are giving less than or equal. No, therefore you have to say the exact value en minus st. Okay, I'll keep as it is. So copy down soon. So are you writing this in your book or you are writing only in the code? Not are you writing only in Python ideally?
Only in Python.
So then, so what is the plan? Otherwise, the next day also you will forget. So can you put dates and save this into folders?
Okay.
Okay. Otherwise, otherwise, what my recommendation is, do the exercise and also do this, write this in your book also with the result of the coding. Otherwise, what will happen? Otherwise, like, you will forget, ne? Okay.
Yes.
Okay, there are some, I think now you can just give a try. These two also, there are some, this two and this two, just try. But now you have some idea. At least, so if you cannot do this one, try to do this one. This one is easy, no? This one going reverse. So here you are going +1, but this one is basically ST -1. You're going reverse. You can try that one at least. Okay, the third one, it's 1, 3, 5, 7. So you can see it's odd numbers. Can you remember how we print odd numbers from 1 to 10? Okay.
You have to add the numbers +2.
Yeah, 2 by 2. Yes, we have to start from 1 and add 2 by 2. So that is it, right? So you got the answer. So that is what I'm telling, right? So if you start from 1 and go up to maybe here 1, 3, 5, 7, no, you can just go up to 9, because like it will not go up to 9, it will end before 9. And then if you can print what? If you can print 2 by 2, if you move 2 by 2, what will happen? This is repetition free and you will get this. So that is why I said, like, so it's always related to what we have learned. And you can see it's 1, 3, 5, 7. But the thing is, there is a, right, there are spaces. How many spaces before this first one? Yes. So there is, it seems like 3 spaces, 2 spaces, 1, 3, 2, 1 maybe. You can just count like 1 space, 2 spaces, yes, 3 spaces, 3, 2, 1. So spaces will be like 3, 2, 1, 0. But the numbers, the asterisks will be 1, 3, 5. The spaces is basically half of that. So spaces is half of that. You can say space is just multiplied by, multiply this by half of 5. But the thing is not, again, half of 5 will not work because it is like 3, 2, 1, 3 going reverse. It's going reverse. So if I say, if I tell like it is something like, okay, 9 minus, so let's say if I'm telling you 9 minus I, 9 minus I, then so let's see what will happen, because it's going reverse, no? It's going reverse. So you can see the spaces come this way. But that is not the expectation, right? That is not the expectation. If you get 9 minus 1, it is more spaces. We have to reduce that. Let's divide it by 2. Let's divide it by 2. 9 minus I divide by 2. Actually, floor division can be applied here. Why? Because you need the integer number. Therefore, 2 division signs, floor division. We need the integer number. Let's try this now. Okay, you can see you are getting the expected output. It's not difficult, right? It's not difficult. 9 minus, actually you can use 8 minus I. 8 minus I, or even 7 minus I is also okay, because we are going up to 7, right? 7 minus I will give the results, doesn't matter, I think. Here, 8 minus 1 is also okay. 8 minus I divided by 2, or you can say 7 minus 1 divided by 2. So let's try for 7 minus 1 divided by 2, because 9 is like 9. We are not going up to 9. 1, 3, 5, 7. So 7 will be enough. Here we are, and you can see even 7 minus I will give the results. Right, that is for the repetition, but I need you to try for recursion. The next one also I'll give the repetition one. You have to try the recursion one, right? I'm not telling you the recursion one. I'm telling you the repetition one. You try the recursion one. This is the fourth one. Fourth one, you can see starting from 1, 2, 3, 4, 5, then 5, 4, 3, 2, 1. So that is easy. You have to start from 5, 4, 3, 2, 1. Then when it's 0, you need to stop. Go -1 by -1, the reverse order. So what you're going to print this time is this I. So it is very, very similar to the first one. Only thing is you're going reverse order. Okay, I have done the fourth one for you. This is the fourth one. So please remember, this is the first one, second one, third one, and fourth one. If you need spaces between these, we can just add print empty line after each for loop to keep some space. Now you have empty line after each space, and when you're running this code, and you can see, okay, this result. I have done all 4, right? Now all 4 are done for you, but only using repetition. What you need to do is you need to try this using recursion. I advise you please write down this somewhere in your book, because otherwise you will forget, or you have to save it and name the folder with the date and the concept. Then you can recall that back. You can open that back and see your code. Whatever mechanism, please apply. Otherwise, what will happen in the long run when you are learning, like when you are learning some advanced concept, in the long run, you will forget. So I'm ever done now. You know these things, right? This is not difficult to you as well. I can understand this is not difficult to you. You know this, but only thing is you cannot recall. The reason is, so what is the main reason? You're not practicing. There is one reason. Maybe you have some other subjects to do and you don't have time to practice these things again and again. But thing is, if you organize these things very well and keep this in a proper order, you can recall that back. So since you don't have enough time to practice these things, my recommendation is keep these things in order. Save it in an order and also write down in your book when you have time, and then you can recall that back. You can turn that page back again, recall that command again, and do it again. So always try to keep the result and as well as the code in the same place. In front of this, if you can draw the result, that is better. Then you will easily remember what will be the result. Otherwise, you have to run the code and see. Okay, now just give a try to apply recursion for the last 2 and also these 2 patterns if possible. Right here, actually, the reverse loop. Let's do this one, the recursion 2, recursion 1, and recursion 2 is this. And let's try for the recursion 3 also on copy and paste in the same thing again. In recursion 3 is what you need to do is you are starting from this, then you have to go 2 by 2, right? 2 by 2. Here actually you need to divide this by 2. So divide by 2. Yes, flow divide by 2, but yeah, ending minus starting, flow divide by 2. That is the spaces. So let's try this as start tree this time and start tree here also. So let's run it and see whether is it generating the expected results. Start tree, and you have to give the starting and ending. Let's sorry, the other way, right? Yeah, starting and ending. 1 to 8, 1 to 7. Oh, just a second. Oh, right. You're getting the ending. Ending is 7. Starting is 1. 4 divided by 2. Actually, you need to bracket this. Okay, let's run it again. Okay, you're getting that. And the fourth is done. Now the fourth one. In the fourth one, you have to start from the reverse order. Like here, you can say the start and ending, you can say the start is bigger, basically. Start is bigger and ending is smaller. Therefore, what you need to do is you have to check other side. Starting is bigger than this, bigger than or equal. Like the starting is whether this starting is, we are checking less than or equal. No, here I'm checking the other side, bigger than or equal. then the number of space, actually we don't have spaces right here. The last one is not having any spaces. No? You can just multiply by st, okay. Then here you have to say st equal st minus 1. You are going reverse order. That is the fourth one. That is easy, I guess. Only thing is you have to compare this in the reverse order and you have to minus 1. I think you missed this part, right? It seems. So what do you think?
I actually did it correct, but I just didn't write it big. I wrote it smallest to big instead of biggest to small.
Oh, right.
Order.
Yeah. So that you need to, okay, let's see now, star 4. Now we have 4 functions, star 1, star 1, 2, 3, and 4. And this time we have to give the bigger number first and the smallest number, smaller number next. And you can see it's going to print in the reverse order. Right now we have 4 functions, normal star functions. You can go from 1 to 5, it's printing 1 to 5. So the next is a star 2 function. So again, you can just move from 1 to 5, it's printing this way. And star 3 function, so when you say 1 to 7, it's printing the other way. So star 1 to 7, star 3 functions printing, it's like a tree top, and then star 4 function. There's a 4th function that we have tried, it's printing the reverse order. So 5 to 1, so you can see this. Now we have done up to this level. But I'll keep that next 2 for practicing. So, but here, so what you need to do is please see how we have got the results also, not just the recursion, not just the repetition, the results, implementation, and the results. So how we have run this in the terminal. Please consider that as well. That is why I said, so do write this in a book. Then with the results, then you will, then when you see this again after some time, you will easily understand the concept. Okay, 2 more to remain, 2 more remaining. So you have like few hours to try. You can just give a try. We can discuss the remaining part tomorrow, right? So that is these 2, Fibonacci and factorial. I think you can find these things if you just do a small search. So you can find how you have printed these patterns that is available. Just go through, try to find that, how we have done this using repetition. Luckily, if you find this, you can convert this to recursion easily. Because once you understand the repetition concept, recursion is nothing. Okay, I'll stop from here for today. Then see you next day, right? Okay.